going to start off our lesson talking about polygons. The reason we're going to talk about polygons first is that polygon means many angles. Poly means many and gon means angle. So we are moving away from, we learned point, line, plane. Those were our foundations of geometry. Now we're going to start to do things with those points, lines, and planes and make them into actual figures and study those figures. So as we study those figures, we are going to zoom in to the smallest polygon first. What's the smallest polygon that exists? Or the one with the fewest sides. I wouldn't call it the smallest. Yes. So we're going to talk about polygons first. And then we're going to zoom in and talk about triangles. And then we'll do quadrilaterals. And then we'll do pentagons, kind of. And we'll go to the rest of the polygons. So let's begin by talking about what a polygon is. Because a triangle falls under the umbrella of polygons. A polygon, and this is on your vocab sheet. You don't need to write this down in your notes. You just fill this in on your sheet. A polygon is a closed plane figure with at least 3 sides or segments. That's a big definition. Let's dissect it. Closed. So in order to be qualified as a polygon, your shape must be closed. So for example, this shape is not a polygon because vertice A is not touching vertice E. There is an opening there. There is no segment connecting A to E. Plane. This is really important to note. To make a polygon, you connect points. But for it to really be a polygon, you have to connect points that are coplanar. So that's a fancy way of saying polygons are flat shapes. So we're not studying 3D figures yet. Flat shapes. So yeah, we need the points, the vertices to be coplanar in order for us to have a true polygon. So we're going to assume that our figures are always 2D. They're never 3D. Our lines are never skew. The lines that make up our polygon, they're always going to be in the same plane. Coplanar. All right. The next one is it's a figure, but that word doesn't really tell us much, with at least 3 sides. That's telling me the smallest polygon I can have is a triangle, but then it doesn't give me any limits after that. I guess I could have a polygon that has 1,000,000 sides. The sides must be segments. So no curves allowed in a polygon. That right there is not a polygon. It's a shape, it's a figure, but it is not a polygon because our sides need to be segments. We have 2 types of polygons. We can classify them. Classify means name. We can classify them as convex or concave. Those are also on your sheet. You might have heard these words in biology, or you might when you get into high school. When you're looking through a microscope or in science class and looking through a lens, convex, hello, can be convex or concave. I'm going crazy now. So what convex means, and I'll show you if it's a lens, it kind of looks like this. And then concave. What convex means for polygon purpose, not for lenses, is that if I were to connect my vertices, aka if I were to draw the diagonals of my polygon, if it is truly convex, all of the diagonals will fall inside the polygon. So connect any of the vertices that you want, connect any of them, and every time you try to connect them, it will all fall inside the polygon. Conversely, when you have even one part of the polygon that's concave, some of the diagonals might fall inside, but you're going to have some of the diagonals that fall outside the figure, like this one and this one. So if your diagonal falls outside, you have a concave polygon. Another way to think about that is that side caved in. It caved in. It's like someone came and pushed on the side and made it cave into the shape. So that's concave. We'll study this a lot more when we have our polygon unit. We're just giving you a background for now. Let's see if we can apply these. Is the figure a polygon? If so, is it convex or concave? Good. That first one, is it a polygon? Yes, it is. Concave or convex? Concave, and there's where it caves in right there. Here's the guilty diagonal, the one that falls outside the shape. What about that second polygon, or that second figure, rather? Because it is not a polygon. When it's not a polygon, you don't classify it. It can't have a classification because it's not a polygon. Good. What about that last one? Yes or no? Yes. Concave or convex? I don't see any sides that are caving in, so it is a convex polygon. All right, so now we're going to use some more vocab words, continuing on here. If a polygon is equilateral, that means all of its what are congruent? Sides. Very good. So, lateral, and it's supposed to disappear, but it's being slow. Lateral means sides. So equa means equal, and lateral means sides. Equilateral, all sides are equal. Equiangular means all angles are equal. These have sound effects if you're hearing them. It's weird. Then, if your polygon is both equilateral and equiangular, it receives a promotion, and it is called a regular polygon, which isn't that great of a name for a promotion, right? Regular seems like it's like ordinary or boring, but actually it's a very, very, very special polygon. So it'll have tick marks on every side, and it'll have arcs on every angle. Let's just name the polygons for fun, and then we'll zoom in and only talk about triangles for the rest of the unit. So, if it has 3 sides, it's a triangle. If it has 4 sides, it's a, don't say square, quadrilateral. 5 sides, pentagon. 6 sides, hexagon. 7 sides. Oh, yep. Actually, I don't have that one. So well, it's hepta or septagon. It's weird. Why do they have 2 names? Just pick one. Hepta or septagon. 8 sides. Octagon. 9 sides. Nonagon, and a good old decagon. And we'll study a few more like dodecagon when we get to that unit. All right. So polygons, we're done with you. We now know what a polygon is. A triangle is a type of polygon. So now the rest of the unit will be about triangles. We are on the back of your notes page, or page 2 if you have that. So classify means sort. I can sort triangles by size, and I can sort triangles by angle. Just like I could sort you guys by male, female. I could sort you by your age. I could sort you by your height, your weight. So this is how we sort this. So if we're going to sort it by its angles, there's 4 words we can use. If all the angles are equal, it is called equiangular. If all angles are less than 90, there's our acute, our right, and of course our obtuse. So you've seen this before. This is a review, so we're going to go quickly. Let's take those 4 words that we just wrote down, and let's see if we can put them in this. What is this called? Isn't it kind of like a Venn diagram? Or a graphic organizer. Some people call them graphic organizers. None of them are intersecting, so it might not be a Venn diagram. Anyway, we're going to put them in this figure. What do you think? Notice there's some overlap here. Of those words, what overlap do you notice? So we've got equiangular, acute, right, and obtuse. Which ones overlap? Go back to that. If a triangle is equiangular, what are its angles measured? What are its angles? They're all 60. Because equiangular means I take 180 degrees and I split it evenly 3 ways. If I split it evenly 3 ways, then they're all 60. Therefore, they're all less than 90. So do you agree that all equiangular triangles are what? Acute. So I could call this circle acute And then every equiangular triangle is acute. But not every acute triangle is equiangular, right? And then we have right, and then we have obtuse. Notice there's no overlapping here. You can't be obtuse and right at the same time. You can't be acute and right at the same time. So notice the only overlapping ones are equiangular and acute. All right. Now we can classify by its sides. I know you know these words really well. Equilateral, isosceles, scalene. Key word, we talked about this earlier. At least two sides congruent. So that's saying two or more sides can be congruent. And it really just means two or three, since triangles don't have more than three sides. But what it's saying is that isosceles triangles can have two or three sides congruent. So there's some overlapping there, right? Let's take a look at that overlapping. I want to do this first, actually. What word goes where when we look at this Venn diagram? For this graphic organizer. What word goes inside the other? Scaling goes in the blank one. Very good. Scaling, you're all by yourself. You're weird. Just kidding. So you're saying isosceles goes here, and equilateral goes here. So that would mean you're saying that all equilateral triangles are isosceles, but not all isosceles triangles are equilateral. And that's perfect. No, that's perfect. All equilateral triangles, do you agree that if a triangle is walking around with three congruent sides, does that triangle have at least two sides congruent? Well, of course it has at least two sides congruent. So if it's equilateral, it's definitely isosceles. If it's isosceles, it might have two or it might have three. So it could be just isosceles, it could be equilateral. So this is just like rectangles and squares. All squares are rectangles, but not all rectangles are squares. Same thing with isosceles and equilateral. Now I know you know the conclusion to this theorem, but I do want to show you pictorially why it works. So I have a scalene triangle here. There's nothing special about this triangle. All the angles are different measures. But if I take my three angles and I line them up, if we had more time in class, I would have you take a triangle and I would have you pair the angles off and I would make you line them up on a line. And you would, of course, come to the perfect conclusion that the sum of the angles of a triangle is 180 degrees. If I line them up, they make a straight line, which has 180 degrees. So that's our story, and we're sticking to it. You already know this, so I'm not going to give you time to write it down. But it is called the triangle angle sum theorem, which is a really long theorem. Triangle angle sum theorem. Okay. What do the sides of a triangle add up to? The angles add up to 180. What do the sides add up to? Great answers. Nothing and depends. Very good. Students get confused when they get to the middle of this unit and they start adding up the sides to equal 180. The sides don't add up to anything necessarily. Not infinite. No, 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 no. But the sides add up to something different every time. So don't try to think that there's a theorem that says the sides of a triangle add up to something. Unless it's a right triangle, and then you can use the Pythagorean theorem. Okay, this theorem may or may not be new to you. This one's called the exterior angle theorem. Haytham, we'll learn that on Monday. We'll learn that on Monday. And they're not lines, they're segments. Okay, exterior angle theorem. So I'm going to show you pictorially what this theorem is, and then we'll write it out in words. I'm going to take angle number 1, and I'm going to translate it right there. I'm going to take angle number 2. I'm going to rotate it, but not change the measure of the angle. And what can we conclude? 1 plus 2 equals 4. Goes against everything you learned in kindergarten. Yes. So what it's saying is that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. This is an awesome shortcut because we could find angle 4 either way, right? We could find angle 3 with triangle sum theorem, and then we could do linear pair, but that would take like 4 steps. Instead, we can use this handy-dandy exterior angle theorem, and we can find the measure of angle 4 with 1 step. You add angle 1 and angle 2. In order to talk about those angles, we need to give them names. So go ahead and write down the names of those angles. So our two angles that are really far away from the angle we're looking at are called the remote interior angle. Remote means far away. Remote means distance. So those two angles are far away from the exterior angle. They're the remote interior angles, like when you're sitting on the couch and you don't want to get up to turn the TV off, you use a remote control. You want to control the TV remotely. Our exterior angle is, of course, an angle that is outside the triangle. But I want to be more specific than that. An exterior angle is formed when you extend a line. Extend a side of the triangle, rather. I'm sorry. I want you to think of exterior means I extend a side. Because here's what people accidentally start doing. They accidentally think, oh, exterior angle theorem. 1 plus 2 equals, and they think it equals that. They're like, that angle is exterior. That angle is outside the triangle. But angle 4 is not an exterior angle. So be careful. An exterior angle is formed by extending a side. So that would be an exterior angle. Or you can extend this side. In other words, the exterior angle is going to be adjacent to the third angle of your triangle. It's not going to be vertical with that third angle. It's going to be adjacent to the third angle. Here's the theorem. The measure of each exterior angle equals the sum of the measures of the two remote interior angles. How many exterior angles does a triangle have? How many? Nice. 6. So there's 2 exterior angles at each vertex. How do you like that? I didn't say vertices. So a triangle has 6 exterior angles. And to find the measure of those angles, you find the remote interior angles that go with it, and you just add them. Let's try it. Oh, we're not going to do class flow because we don't have time. All right, angle x. What's the measure of angle x? Shortcut, use it. Go. Yay! You add the remote interior angle, and you get the exterior angle. Number 2, go. You add the remote interior angles, and you get the, oh, why that's at 96 again. Hello. And you get the exterior angle. Let's try some tougher ones. Try this one, please. You're all getting X's 5. You're all amazing. So we add plus sign. We add the remote interior angle to equal the exterior angle. We combine one term. 8x plus 1 equals 3x plus 26. 5x equals 25. All it was asking for was x. They didn't want us to plug back in, so we can move on with our lives. Try this one. What I recommend on a problem like this is you're going to need to find another angle first before you find x. I would give that angle a name just so that you can write an equation if you want to. So I named those both y because they had arcs. So what I would do is I would use our handy-dandy new theorem that we just learned. And I would say, oh, if I add my remote interior angles, it will equal my exterior angle. So I'm not even focused on x right now. I'm just trying to find those angles right there. So I would say 90 plus 2y equals 177. Is that okay? So we subtract 90 from 177. 2y equals 87. Uh-oh. Decimal warning, decimal warning. Y is 43.5. We're allowed to have decimals, don't be scared. So I've now found this angle. It is 43.5, and now I can find x using the triangle angle sum theorem. Or if you understand how triangles work, how right triangles work, I can just subtract it from 90 because in a right triangle, the other two angles add up to 90, if that makes sense. 46.5 is the final answer. Some people like to, let me erase this, but you're not really using our new theorem if you do it this way. Some people like to do linear pair, which is really weird because that's a 3-degree angle. And then they like to use this triangle and find y that way. Because we know 3 plus our 2y is going to equal 90 because when you use up 90, there's 90 left to split. So anyways, a couple different ways that you can do that, but it still was a multi-step problem either way. You couldn't have found x right away. Nice, guys. So when you see that word ratio, you think, oh, I attach an x to it. Because it's not the measure of the angle, but it's a representation of kind of like a factor, multiply. So we can represent our angles with 1x, 3x, and 5x. And then we know by triangle angle sum theorem that they add up to 180. So 9x equals 180. Nice. X is 20. And then we plug it back in. So this angle is 20. This angle is 60. This angle is 100, making it an obtuse triangle. Yay! Last one. The ratio of the measures of the acute angles of a right triangle is 2 to 3. Find the measures of the two acute angles. Nice. Thank you. Good job. So just like we were talking about in that previous problem, this is going to come up so often that you just go ahead and get used to it. When you have a right triangle, the two angles that are left always add up to 90. Don't add the angles up to equal 180. Don't do that in a right triangle. Every time, just add these two to equal 90. So yes, 5x equals 90. X is what, 18? And then we plug it back in to get 36 and 54. Awesome.